Hello everyone. Today I am going to show you how to find mean, median, mode, range, standard deviation for a sample and a population, finding variance for a sample and a population, how to find the 5-number summary, the minimum, quartile 1, quartile 2, quartile 3, maximum, how to find the inner quartile range, how to find the lower fence, upper fence, and locating whether or not you have outliers. I will show you by hand, by calculator, and through Excel. So let's go ahead and get started. So given this data set, we have 21, 2, 10, 2, 8, 3, 7, 5, 5. The first thing you want to do when you're doing this by hand is to put your numbers in order. So let me go ahead and do that. And I'm going to create a table. And I'm going to label our data values as the X column. So putting these in order, 2 is the smallest. We have 2 2s. And then 3. Five, another 5, 7, 8, 10, and 21. Double count these numbers again to make sure you included everything. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Okay, so we got them all. So the first thing you want to do when you find the mean is you're going to add up your data values. So finding the mean, you find the sum of your data values and divide by how many numbers in the data set. So we have 9 numbers. And let's go ahead and add up all these numbers together. So I'm just going to grab my calculator. Of course, you can add these by hand, but to save some time, I'm just going to add them in the calculator. 2, 2, 3, 5, 5, 7, 8, 10, and 21. I get a total of 63. So our mean will be 63 divided by 9, which is 7. The median is the middle number. So since our numbers are in order, I'm just going to cross one off in the beginning, one at the end, beginning, end, beginning, end, beginning, end. And it looks like 5 is going to be our median. Now, as a side note, if you have 2 middle numbers, then your median, you would add those numbers together and divide by 2 to get the median. But in this case, we have 9 numbers, so we won't have 2 numbers in the middle because it's odd. All right, the mode. is the number that occurs the most often. So if all your numbers repeat only once, then you have no mode. So let's see if we have any numbers that repeat in our data set. We see that 2 repeats twice and 5 repeats twice. So in this data set, we actually have 2 modes, 2 and 5, because those are the numbers that repeat the most. They repeat 2 times. Next is finding the range. The range is your maximum value from the data set minus the minimum value from the data set. Well, in our table, we put these numbers in order. Your maximum was 21. The minimum was 2. Subtract those, you get 19. Let me go ahead and clear the board. Now finding the standard deviation for a sample and a population. So let's start with writing out the formula for the standard deviation of a sample. So S for sample equals the square root of the sum of your x values squared minus the sum of your x values squared in parentheses divided by n, all divided by n minus 1. Some books give you this option as the formula, where you take the sum of each x value minus the mean squared divided by n minus 1. You can do this formula, however, this one takes more time. I prefer the first formula I gave you. It's my version of a shortcut. And I prefer that because it's really helpful using the table that I have displayed here. So in this table, what you're going to do is you're going to break this formula down. The formula has x squared, and we need to find the sum of that. So go to your table, and you make an x squared column. So you're going to square each number. Well, 2 squared is 2 times 2 is 4. 2 squared again is 4. 3 squared, 3 times 3 is 9. 5 squared is 5 times 5. 5 squared again. 7 squared, 7 times 7. 8 squared, 8 times 8. 10 squared, 10 times 10. And 21 squared, 21 times 21. If you don't know it, pull up your calculator. 441. And go ahead and find the total of all those numbers. So 4, 4, 9, 25, 25, 49, 64, 100, 441. 721 is our total. So this total was the sum of our x squared. And the first column was the sum of our x's. We need those totals for our formula over here. So this here is the total we found of the second column, 721. And in parentheses here, is the sum of x, which is the sum that we got from the first column. So down here at the end of our table, the sum of our x's was 63. The end value, we had 9 numbers. And then we had 9 minus 1. We can go ahead and simplify this. So when we break down this radical here, the square root, you want to start with the parentheses. 63 squared. I'll go ahead and put that in the calculator. 3969. And then I want to get rid of that fraction. So in the calculator, the 3969 divided by 9, 441. Now we can subtract. 721 minus 441 is 280. And 9 minus 1 is 8. Go ahead and divide those two numbers. So 280 divided by 8 is 35. Excuse me. And then the square root of 35. $5.916079783. You don't need to write out all your decimals. I did, just for examples purposes. I just wanted to use all the numbers instead of rounding. All right, so let me go ahead and clear the board. So that is the standard deviation of a sample. Now I'll go ahead and find the variance of a sample because these formulas are related. The variance is S squared. You can use the formula if you want to. The only difference between the standard deviation and the variance is the standard deviation has the square root and the variance does not. S and S squared. Well, we already found S. The sample standard deviation was 5.916079783. So to get the variance, S squared, you're just going to square the standard deviation. And put that in your calculator. You're welcome to go through all the steps again to calculate it using the formula, but it's not necessary. As soon as you find one, you can find the other. So I'm just going to go ahead and square this number. So 26,999. Again, you can decide if you want to round, but I'm not going to. 26,999,24511. If you were working from standard deviation to variance, you would square it. So you raise it to the power 2. If you're going the opposite way, if you're going from variance to the standard deviation, you would do the opposite operation. So instead of doing the square, you would take the square root. Remember, the standard deviation had the square root in the formula. So you take the square root of the variance to get the standard deviation. So these two go hand in hand. When you find one, you can easily find the other. Okay, so that was for the sample. So now let's do the standard deviation for a population. So we no longer use the letter S because we're working with population. You use Greek letters. So population standard deviation, we use sigma. Now the formula is very similar. Except we don't have the n-1. So let me go ahead and erase the n-1 because we don't need that. All right, let's go ahead and calculate the population standard deviation. So the sum of our x squares was the 721. That was our totals at the bottom of our table. The sum of x squared was 63. We had 9 numbers, all divided by 9. Again, break this down into steps. I'm going to get rid of the parentheses by squaring the 63, and that was 3969. And we divide that by 9. And we got 441. Go ahead and subtract. We get 280. Go ahead and do 280 divided by 9. (31) with 1 repeating. And then take the square root of that. So square root of 31.11111. I get 5.57. Again, you can decide if you want to round. I'm not going to. 5.57773351. And now we need to find the population variance, which is sigma squared. Well, we already found sigma. Sigma was the 5.57773351. If I square that, then now I get the variance. So sigma squared . 311 and 1 repeating. 31 with 1 repeating. And if you don't see the connection, this number is actually right here before we took the square root. Make sure you type your numbers in properly, because I did not calculate that standard deviation properly. When we had the sample standard deviation was the square root of 35, I had 5.91, but when I went back and typed it in, I switched it to 19. So make sure you type your numbers in correctly. Let's write our results here. The population standard deviation sigma is the 5.5777. The variance, population variance, was the 311.1111. The sample standard deviation S was 5.91608. So the variance, sample variance, S squared, should have been 35. So please watch your numbers when you type in a calculator. Mine was a perfect example of error. So, all right, moving on. Our next calculation, let me go ahead and clear out our white space here. All right, so we found mean, median, mode, we found the range, we found the standard deviation for our population and sample. We've also found the variance for our sample and population. Now it's time to work on our 5-number summary. So minimum. Well, remember in the very beginning, we already put our numbers in order. So our minimum is the first number on our table, which was 2. Quartile 1, quartile 2, quartile 3. When you're finding quartiles, you always want to start with quartile 2. Quartile 2 is 50% of the data, which is also the median. And we already found the median, but let's go ahead and show you again. Cross off the smallest number and the biggest, and just keep crossing off numbers until you get to the middle. So our median was 5. Now let's find quartile 1. Quartile 1 is 25% of the data, which is going to be the median of the first half of your data set. So that means all of these numbers here before the median. So cross off, whoops, excuse me. Cross off, and we're stuck with 2 numbers. So to find the median between 2 numbers, you add those together and divide by 2. So your quartile 1 comes out to be 2.5. Quartile 3 represents 75% of the data. So that means you're going to be looking for the median of the second half of your data. So your median, after the median, are these numbers here. Cross off, cross off. We stuck with 2 numbers as the middle. We're going to add those 2 numbers together, divide by 2. So quartile 3 comes out to be 9. And then the last number for the 5-number summary is the maximum, which is 21. That is the highest number in our data set. Now, with the 5-number summary, you can create the box and whisker. You can draw a number line here at the bottom. Our minimum was 2, and the maximum was 21. So we need to go all the way up to 21. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Clearly I went too high, but I wanted to leave some space here. All right. So we'll stop at 30. All right, so the minimum, we start here, just put a dot here. And let's find the maximum. Right here, here's 21. And I'll put a dot there. So here's minimum. Here's maximum. All right, go ahead and find quartile 1, 2.5. So that's about right here. I'm going to draw a line. Quartile 2 is at 5, which is here. 9. There we go. And then you make a box to connect all your quartiles, and then draw a line as your whisker to the maximum, and then draw a line as your minimum. Can't see it, but there's a line here between quartile 1 and the minimum. So there's your box and whisker. Dot for the minimum, you have a whisker to quartile 1, draw a line for quartile 1, line for quartile 2, line for quartile 3, draw a box connecting all your quartiles, and then maximum with another dot and a whisker between quartile 3 and the maximum. All right, so next on our step of list here, we want the inner quartile range. All right, I'm going to leave this box and whisker here because we're going to need it. All right, so the inner quartile range abbreviated as IQR is your quartile 3 minus quartile 1, which we've already found. Our quartile 3 came out to be 9, and quartile 1 came out to be 2.5. Go ahead and subtract those. $6.5. That's done. Next on our list is to calculate the lower fence and the upper fence. Our lower fence is going to be Q1 minus 1.5 times our inner quartile range, IQR. Our Q1 was 2.5 minus 1.5 times the inner quartile range, 6.5. You want to multiply first. $9.75, and then subtract. I get negative 7.25. That's what we call the lower fence. Let's go ahead and calculate the upper fence. Upper fence is Q3 plus 1.5 times the inner quartile range. So Q3 plus 1.5 times the inner quartile range. Again, you want to multiply first. And add these together, you get 18.75. All right, so I'm going to go ahead and label our upper and lower fence on our table here. 21, 20, 19, 18. So probably right about here is our upper fence. So that means from this point here to the maximum, all of these numbers are considered outliers. And our lower fence is going to be way over here. And there's no numbers here after our minimum, because our minimum was 2. We don't have any negative numbers or any numbers less than 2. So we don't have any outliers by the lower fence. But I'll go ahead and write out our results here real quick on what I mean by outliers. So outliers, any numbers from the data set that is smaller than the lower fence, which in our case is negative 7.25, and numbers bigger than the upper fence. In our case, our upper fence is 1875. So any number smaller than negative 7.25 and any number bigger than 1875 are considered outliers. Well, our numbers in our table are in order. We don't have any numbers smaller than 2, so we don't have any negative numbers. And our largest number goes to 21. Well, our outliers start at 1875. So looking at our numbers, 21 is definitely bigger than your upper fence. So 21 is an outlier. And if you want to put your explanation, you can put because it is bigger than your upper fence. And that answers all of our questions. And this is doing it by hand. If you want to skip through the video, you can. Now I'm just going to show you how to do it in the calculator. It's a lot faster. But if you prefer doing it by hand, then fantastic. I've already showed you all the information you need to know. But let's check our answers in the calculator. You press the stat button right here. Under edit, you just press enter. If there are numbers here, go ahead and clear them out. You go up to highlight the title of your column. You press clear, enter. And let's clear out the other list. I scrolled over, press up, highlight the title of the column, clear, enter. So your lists are cleared out. Let's go ahead and put in our numbers. I'm just going to type in the original set here at the top. 21, 2, 10, 2, 8, 3, 7, 5, 5. If you want to sort them, you can. To sort them in the calculator, you press Stat, Sort Ascending, so number 2, and you tell them what list your numbers are in. So your lists are in L1, so press second number 1. It's here in blue where it tells you the title of your column, L1. Press enter. It says done. It sorted your numbers for you. So let's check. Stat, under edit, press enter. And look, our numbers are in order. You don't have to have the numbers in order when using the calculator, but you can if you want to. So now let's do our calculations. Press stat, go to calculate. So scroll over. We want number one variable stats. Make sure your list is there. So L1, if it's not there, you press second number one. Some calculators are updated. They're going to ask for their frequency list. We don't have a frequency list right now, so we're leaving it blank. Go to calculate. At the top is your mean, X bar. Summation of X, 63. Well, that was our total column here from our table, 63. And then the sum of X squared, 721. Well, that was the total of the second column. SX is our sample standard deviation. So here's that number. Sigma X is the population standard deviation. We have 9 numbers. There's our minimum, our quartile 1, median, which is also quartile 2, quartile 3, your maximum. The only thing it did not provide you was the variance. So I showed you how to do that by hand. You take this number squared to get the variance of the sample, this number squared to get the population variance. The IQR, Q3 minus Q1, the range, maximum minus the minimum. In the upper and lower fences, I provided those formulas to you already, so you just have to plug your numbers in. And outliers, again, just look at the numbers from the upper fence and the lower fence. And that is how you do it in the calculator. Very fast and easy. Stat, calculate, variable stat, calculate. Boom. Now, if you're doing it through Excel, go ahead and type in your numbers. These numbers, again, don't have to be in order, but if you prefer your numbers in order, you highlight them, right-click, sort, smallest to largest. To find the mean, you press enter, average, double-click, and then highlight your data values, press enter. Median, equal, median, double click, highlight, press enter. Mode can't be found in the calculator or through Excel. You're just going to have to look to see what number occurs the most often. In this case, 2 and 5 repeat 2 times. The standard deviation of a sample equal STD EV.S for sample, double click, highlight, press enter. The variance for a sample equal VAR.S, double click, highlight, enter. The standard deviation for a population equal STD EV.P for population, double click, highlight, press enter. VAR.P, oops, sorry. The variance for population equal VAR.P, double click, highlight, press enter. The minimum equal minimum, double click, highlight, press enter. Quartile 1 equal quartile.exclude, excludes the median. You could use include if you want to include the median. But for our example, we're going to use exclude. You highlight your numbers and then comma 1 for quartile 1. Press enter. Q2. Remember, Q2 is also the median. So you can use the median formula or the quartile formula. I'm going to use the quartile formula since I typed it as Q2. So double click on quartile exclude, highlight comma number 2 for quartile number 2. And obviously you can check that this quartile matches our median from earlier, just to show you that those are related. All right, now we need Q3 for quartile 3. Double click, highlight comma number 3 for quartile 3. The maximum equal MAX. Highlight, enter. Now the range, you press equal, click on the box for maximum minus the box for minimum. The IQR. Let me type the formula in here real quick. X minus. That way you have the formula there. The IQR is the Q3 minus Q1. So equal Q3 is right here minus Q1. Press enter. And then we want the lower fence. That is Q1 minus 1.5 times the IQR. So equal Q1 minus 1.5 times the IQR. And then the upper fence, that's Q3 plus 1.5 times the IQR. Equal quartile 3 plus 1.5 times the IQR, and then outliers. There's going to be numbers smaller than negative 7.25 and numbers bigger than 18.75. So we already put our numbers in order. So any numbers that are smaller, I don't know why that negative won't move over. There it goes. So any numbers smaller than negative 7.25, we don't have any. And any numbers bigger than 1875, excuse me, which we do, 21. So 21 is an outlier. And there you go. If you are wanting to build your box and whisker, you want to go to Insert. You want to click More Charts. Oops, highlight these numbers first, and then click More Charts. All charts. Go down to Box and Whisker, and here is your chart for the box and whisker. And that dot is the maximum. The minimum is down here. So there's your numbers. You can make this bigger if you want to. And there you go. If you have questions, please contact the UNT Dallas Learning Commons for extra help. Have a good day.